in Kempton, Vermont, and also have a lot of surfing trips and a lot of hiking and barbecue events. All right, so this is kind of like the end of introduction slide, and feel free to scan the QR code. This is our official WeChat account. So this is we're a nonprofit 501c3 Austin. So and this is roughly the 50th time where we have a seminar, and all seminars are free. We're not a training camp, not a boot camp. We do not charge any money whatsoever, and this is 100% reliant on donation and people's free time. So, and if you are inspired to become a speaker for us, come talk to us afterwards, and we would like to, get a feel of, what you want to talk about, and then maybe there's an opportunity where we can carry on this torch and then help others grow, and also helping you to, gain those public speaking skills moving forward. All right, without ado, this is a data science talk, and I think this is probably number 5 data science talk we had. We had quite a few different talks, ranging from accounting, finance, and MBAs and consulting, but for data science, this is the 5th one we had. And so I'd like to introduce you to the 3 speakers I have. So we have 90 minutes allocated for the 3 speakers. We'll start off with CYPN in the finance industry, and then we'll move on to Dreamling and our he works in the finance or pharmaceutical and bio industry. And lastly, we have Liu Chen, who works at TJ Maxx retail industry. And we'll talk about how data science has application, how we have application with data science across the 3 different domains. At the same time, we'll also have opportunity to talk about the career path within data science. How do you get promoted? How do you move from individual contributor to a senior to a management level, and then moving on forward to the highest tier? And also, there is a lot of discussion. I saw the survey question we sent out when you fill out the registration. There's a lot of questions to be asked or to be answered. How do you get into this data science profession in the first place? And there's also things we want to talk about is soft skills. What do you need outside of R, Python, and SQL? What kind of things you can improve on the communication side, business acumen, the project management, etc. So we'll talk about all of this. Hopefully, I have enough time, so I'm going to keep my time short. And also, we have roughly 30 minutes of Q&A that opens up to everyone else. And so I think this is so I'm going to hand my mic to CYPN after also the quick something about myself. So I am Daniel, and I am currently the VP of Business Analytics that manages the data science and also business intelligence for Revolve Group. So, again, I'm in the similar domain in this time, so I'll be hosting this event. And any questions you guys have, feel free to come to me, ask about it, or come to one of those 3 speakers. All right. So I think we're going to hand off the mic to CYPN. All right, and I'm going to stop my presentation.
Okay. Thank you, Daniel. Okay. Good afternoon, everyone. I'm very honored to be invited and give a talk in this event. Because I just feel Daniel's voice is a little unstable right now. So if you still feel my voice is unstable, please just let me know. Okay. My name is Tianxia, and currently I'm a data scientist at Citizens Bank. So today I will first have a brief introduction to credit risk modeling in consumer banking, and then dive a little deep into a scorecard model example. And finally, I will share my thoughts about automation in data science. So I hope you would find it interesting and helpful. So okay, let me quickly go through my background. I graduated from Boston University in 2017 with a master's degree in statistics, and then joined TripAdvisor as a data science intern. After that, I worked at Citizens Bank as a data scientist till now. The first year at Citizens Bank was more like internal consulting. So our team was responsible for advanced analytics and modeling for different products. And 1 year later, our team started to focus on the risk management in personal loan, and also had exposure to some other products like credit card. So I see many people ask, what does a data science day-to-day look like? So I have to say it really depends on the role. So for example, in the first year as a entry-level data scientist in an internal consulting team, I think maybe 50% of 60% of my time is about the coding and doing analysis. It's more like an individual contributor. So, and you will maybe spend 20% of the time to communicate with some other teams and 20% time to talk with your boss, something like that. And then when we really own our business, when we really own our personal life, maybe only 20 or 30% of the time is about the doing analysis or the modeling. Most of the time is about the communicating. Have different meetings with different stakeholders, and you have to ask any question from any managers and people from high-level business, any problems from other teams. So it's really important you have a good communication skills and also time management skills. So okay, then so you could see basically my experience was more about the unsecured loans in consumer banking. So what are the unsecured loans? An unsecured loan is a loan that is issued and supported only by the borrower's credit and is approved without like something like collateral. So for example, like the student loans, the credit card, the personal loans, and the merchant finance. So merchant finance means something like if you want to buy an iPhone, but you don't have 100 or 1,000 bucks, so you just say, hey, can I pay it with Citizens Bank credit card, and I can pay it for 24 months, something like that. So okay, so if the customer, in this case, if the customer stops to pay, the bank will almost lose all the money in the remaining balance. But on the contrary, if the customer with a secured loan product, like the auto loan, and he stops to pay, then the bank could call the third-party collection company, and the company could find this customer, get the car, and sell the car. So finally, they could still get some money back. So the unsecured loan is much riskier than the secured loan, and it is really important to understand and control the risk. So that is my team, the credit risk management team. And the most important risk in such background is the expected loss. Basically, it means, hey, no matter if you are good customers or bad customers that will finally stop to pay, or you are fraud, you will go bankruptcy, we have to have overall expected loss for you. So something like if we originate like 1,000 or 10,000 loans, how much money we will lose in average. So basically the expected loss model, and it's one of the foundation model in our background. So basically it has the three components. The probability of default, basically it will something like the binary classification models. It will predict if you will go default in the lifetime. Basically, let's say if it's a 3-year loan, if you will become default in the 3 years. And the second component is loss given default. Basically, it represents amount uncovered by the lender after selling the underlying asset if the borrower defaults on a loan. Basically, it's more like the auto loans, as I mentioned. So, for example, the auto loans, if the customer becomes a default, then you could sell the car. So basically, let's take it in example. So basically, in this case, auto loan, sell the car, you could get 20% money back. So we will still lose, the bank will still lose 80% of the total loan. So in this case, LGD is 80%, and let's say from the model, we predict this customer will have 10% probability of default. And finally, the third component is EAD, is exposure at default. So it is a predicted amount of loss a bank may be exposed to when a customer defaults on a loan. So basically, let's say this auto loan had 5 years. And in average, we will expect this customer defaults after 2 years. So basically, roughly, this customer will pay 40% of this loan, and there is 60% of balance remaining there. So basically, if you put these three components together, you will see it's 4.8%. This is lifetime expected loss. So intuitively, if you're a bank, okay, and you must have an interest rate or the price for this loan higher than this expected loss. And when you do some marketing, it's also very important, and it will also impact your marketing strategy. So that's why the expected loss model is very important here. And this is like what I mentioned here, PD, LGD, EAD. This is a very traditional way to calculate the loss. In some insurance companies, they will use some generalized linear models like 3D regression model to predict loss. Yeah, there are many interesting methods to calculate the loss. Okay. And besides this expected loss model, another model that you will always hear about in the bank is a scorecard model. So honestly, any model could be a scorecard model, like classification or regression model. A scorecard just transforms the model output to a range of scores, like 300 to 800 or 400 to 900, and use this score to help make business decisions. Sorry, I could still hear some background. Could someone else just unmute themselves? Okay, thank you. Okay, so basically, according to the purpose of this model, we could say we have application scorecard, behavior scorecard, and collection scorecard. Application scorecard is something like, let's say if you have FICO score, and we say we will only approve like the FICO score with 700 above, so it's something like the application score. And the behavior score, it will be used to something like the credit card, right? For example, a student loan or personal loan, if you have a fixed rate, and once you get this loan, the bank has nothing to do with you. But for the credit card, if we think, this customer is getting more risky, we could do something like the credit line decrease, or we could freeze the balance transfer. So we could do something else to control the risk. So we could have this kind of different scorecard. And besides all these modelings in the credit risk, we also have something else, like the pricing models. As I mentioned before, if you could have like loss model is a key component for the pricing model. And we also have the market response models. And the fraud is becoming more severe and interesting problem in the banking, and more different kind of fraud. It's not just the bank, it also happens in the e-commerce. Really different kinds of models, different kinds of fraud. Some fraud, like we have third-party fraud, first-party fraud, synthetic fraud. So typically in the bank, there was a large team to deal with the fraud. Okay. So next, I will just go a little deep into an example. Let's just take the FICO score, the Vantage score as an example. It's also a very famous scorecard model. So FICO score company created the FICO score, okay? And Equifax, this company created Vantage score. So they both predict the likelihood that the person will fall at least 90 days behind on a bill within the next 24 months. Basically, it means this customer start to pay anything for 3 months continuously. So if you have like some credit card, like Discover, you could go to your app and check your FICO score. For example, this is a screenshot of the FICO score dashboard. You could see, hey, you could see you have a score here and a range of these scores, and you have a different component here, and they will tell you why your FICO score increase or decrease last month, and it will also give you some reasons here, like the first reason here is the length of time accounts have been established. And the second is the lack of some reason installment loan. something like this. So basically, there are a total 5 or 6 different categories for the attribute we will put into this kind of models. So basically, the bank will always purchase some attribute from the vendors like Equifax or FICO. They will provide some monthly updated attributes for you. So in each of these categories, we will have thousands of attributes there, like payment histories, the credit usage, like the utilizations, like if you have 5 credit cards and totally you have 10,000 credit line, and how much you will use in each month, and the length of credit history, and types of accounts, and the recent activities, like how many accounts you opened in the last 3 months, 6 months, 12 months, or 24 months. So all these factors will impact your score generally. And basically, one thing you will find interesting here is that the reasons here. So basically, this is also the difference that between a standard, a traditional scorecard between machine learning models. So we have many compliance and regulations in the banking. So every time we build a scorecard model, so like we have to provide some rejection reasons. So for example, hey, if we create some kind of scores like FICO score for the behavior score, we have to provide the reasons why your score increase or why your score decrease. And if we create the application scorecard and we use this score to reject you, we have to provide some rejection reasons. Okay, let's say so more mathematically, it's more like the most important attributes in that model. So it really emphasizes more on the interpretabilities in the model. So in the next slide, sorry. Okay. So in the next few slides, I will just talk a little more about the scorecard modeling process. I will skip some model training or validation steps. I will just talk more about something I feel is more interesting, and this kind of technique is not widely used in other industry. So basically, I think most people know the bank will just use the logistic regression models, or actually logistic regression models is still widely used maybe in most of the industry. Maybe I believe 50% of all the models actually the industry use will be the logistic regression model. So basically, at first, we also do some data cleanings, attribute selections, feature transformations. And I will talk more about WOE, the weight of evidence, attribute transformation technique. And then we use logistic regression to train the models and do some validations. And finally, we will score each account. Basically, I will talk more about how do we transform the probability to a range of scores. Okay, so this is the attribute transformation. Sorry. I'm sorry. This is an attribute transformation technique we always use in the scorecard, and it's a weight of evidence. Basically, for example, this example, we have attributes, let's say it's age, it's continuous variables. And we will first create 5 bins for this attribute. And we will just calculate the number of good accounts and bad accounts in each bin, and also calculate distribution for good accounts and bad accounts. And then we will just use this formula to calculate the WOE transformation. And finally, we will use this WOE value instead of the raw value in the model. So it sounds like not very fancy, but one thing is it will help to this attribute to create some value, like it's monotonic, and it is very important in our bank because only when this trend is monotonic, it could help us to create some rejection reasons. And this technique also requires something like have at least 5% of observations in each band. I know there are some other techniques like the one-hot encoding or something else, and it's true. When we build some machine learning models with some other like random forest or gradient bootstraps, we do not need this kind of feature engineering techniques. So basically, we will use it more with logistic regression. And recently, when we move to some machine learning models, we will not always do these feature transformations. Okay, once we do this feature transformations, let's say we already fit a model, because I don't want to waste time talking about the model building process. So let's say we have a logistic regression models, and we have WOE value for each attribute, and we will use the WOE values and the attributes from the logistic regression to help us to score this customer. So this is also another example. Let's say totally we just have 3 attributes here, and according to this formula, blah, 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 we put the WOE value, the attribute, the feature from logistic regression model, and also other coefficients there, we could have a score for each category and for each attribute here. So according to this table, every time a customer comes in, we could have a score for this customer. And let's say this is the total score for this customer, and then we will create a cutoff for the specific product. Let's say the cutoff value is here. So we could use this cutoff value to make some decisions. Okay, and why do I say the monotonic trend in WOE value is very important here is if we want to reject any customer, let's say our cutoff value is 600, and in this example, his income is 38,000. And now we have another customer, his income less than 10,000. So he only have 120 points for the income attribute. So totally, he will not have 600 points. So, and then we want to create, so our decision is reject this customer. And then we want to create some reasons for the rejection. We will first also, according to this population, this table, create some neutral score. Basically, it's something like in the average, what kind of this customer looks like. Basically, maybe in the average, maybe he will have like 26, 29 years old and own the house, and maybe in the middle income band, maybe we will have a 610 points for this customer, and then we will calculate the difference that this rejected customer and also this neutral customers in each attribute. And then we will rank this difference and find the top 3 attributes, and then that top 3 attributes is the reason for our rejection. Okay. And finally, about the scorecard modeling, last thing I want to talk about is regex inference. Basically, you could think about, we always call all the total applications right through the door, okay? We will accept some customer, also reject some customers. And in the accept customers, let's say we have 2 or 3 year performance, okay? So we know what kind of customers are good, what kind of customers are bad. So basically, and we will build a model just based on this population. But honestly, we will use our model to the total applications. So basically, this customers is not in our model. So how do we deal with this problem? So basically, it's just like this chart. We have good, we have bad, but they're all accept customers, but we will use this model to the total applications. So one thing to deal with it is if we can know more data about these reject customers. Let's say they don't have any loan in our bank, but finally they find another loan in some bank else. So we could have some performance in this bank from some vendors. So we call this the off-us performance. Yes, so getting more data is always the optimized method in the data science. So this is the optimized method. We could have the off-us performance for this reject population. And then if we can't, what we do is we just randomly assign, the most simple way here is just randomly assign good and bad to these customers, and also put this population together with our accept populations, and run the model again, validate this model just like this. It's reject inference. And we will do this again, and finally we can find the optimized model for the total applications. Okay. Okay, finally, I will talk a little more about automations in data science. The reason why I want to talk about it is last year, our company used H2O. I believe many people know this tool. It's an automated machine learning tool. It helps you. You just have to put data into this tool, and it would automatically build the optimized model for you, do the feature engineering. So as you see, in the traditional scorecard model, we only use WOE transformation, but here it has more than 40 or 50 attributes there. Oh, sorry, the feature engineering or transformation techniques there, and it will go through each method and then find the optimized method. And there are also over 50 candidate models there, and it will automatically do the cross validations, out of times validations. I feel, wow, it is really powerful. And then I feel, okay, the bank has this machine. Does the bank need any data scientists in the futures? But when I look at the output from this H2O machine, I realize, oh, at least in the short time, they still need the data scientists, because sometimes you will feel, this models looks good, but it seems like it does not make any sense for some attribute. Some attribute is counterintuitive, and some attributes you cannot explain some attributes, like it just like simply, let's say they have a production of age and the number of credit card you open in the last 3 months and divide by the total balance you have in the student loan. They will find some optimized solution mathematically, but maybe actually it does not make any sense. It's also important because maybe it will optimize in the training data, but it will become it's very easy to become overfitted in the future. And it's also important for us to interpret the model. So although the H2O, they say they can provide something like the model interpretation solutions, but so far we still feel it's not good. Okay, maybe it's not the perfect solution for the automated machine learning, but we can still see this trend. And the trend and everything will go to the cloud, and there must be some more and more tools to help us to build some automated machine learnings. So how to avoid being replaced by a robot? I think the first most important thing is our domain knowledge. So as I mentioned, maybe some machine could create something that it seems like mathematically significant, but it's more important to use your domain knowledge to find some trend behind the data. And also, machine can only build a model. He cannot ask questions, and he cannot say, why do you want to build a model? So you should have to be a person that raise the questions and find some problems, and also know why do we want to build a model? What kind of outputs do we expect? And the second, the soft skills. Yes, many people talk about the soft skills like storytellings, like proactive problem solvings, and effective communications. So if you are just the modelers, like sometime before in the bank, you will see many people, their title is SaaS programmers. They will just solve the problems. So they don't have to have meetings or communicate with other teams. And this is the most important thing that data scientists should do. The scientists should define the problem and then solve the problem. So yes, I know other two speakers. I think other two speakers will talk more about the software skills, so I will leave this part for them. And finally, we should keep learning and growing. And we know there are more new methods, new models, new techniques, new tools in the data science. Like maybe 2 or 3 years ago, if you go to some online course, want to learn something about the data science, it's about SQL and the Python. And now you will see more and more free course about the Spark, about the deep learnings. So you have to, although the soft skills are very important, but we also have to reach the whole, also have something like the hard skills, the coding skills, modeling skills. Okay, I think that's all about my part. So Daniel, do you want to take over? Or Junling, you can just start to present.
Can you hear me? Can you hear me? Okay, so
yes.
Yeah, I'm gonna hand over to Johnny at this point. Really appreciate your very insightful sharing of your knowledge and domain, and we'll get back to you with some questions afterwards. So I think in the interest of time, we already spent roughly 30 minutes, so let me get over to Johnny. All right, so. All right, Juning, you're up.
Sure, Daniel, are you able to hear me?
Yes, I can hear you. Okay, I'm gonna mute myself now. Thank you.
Sure, let me share my screen then. So you guys able to see my screen here?
Yes, we can see you.
Okay, cool. Hi, everyone. My name is Juning Jiang. So thanks for having me here. Currently, I'm working in Water School Health as a senior data scientist. I joined the company basically November of last year. So before that, I was working as a senior algorithm engineer in another startup company in Cambridge. And before that, I was studying my graduate program in University of Florida from both computer science program and also another PhD program in chemistry. So before I prepared today's presentation, actually I reviewed the questions from some of the surveys there. So it looks like most of the questions are more about the career and even what is a data scientist and what is data scientist doing, and even what is data science about, and how to become a data scientist from different fields. So because they are very close to somehow like my experience there, so today I guess I want to just try to cover some of those questions there during maybe next 20 or 30 minutes. The title I'm trying to present is think like a data scientist, because I think this is important in two ways. First one is because most of the topic after this one is somehow related like this one. Also, second part is I believe to work as a data scientist or any other type of data involved jobs, we have to like think like a data scientist first before we're able to even do any like work there, just because of the industry itself. So if there are more questions we didn't cover here, I'll be happy to take like any more during the QA session. So there are a lot of buzzwords in industry right now. For example, a lot of people are talking about like AI is very powerful, or even data science is very powerful. They are going to replace everything in the future. Or someone are saying like data science actually is maybe a bubble. So for a few years, this industry may be just like going away. This is kind of supported by some example, because some companies, they have a data science team, and all of a sudden they lay off the whole team. Actually, based on my observation, actually I believe data science and also the AI, I think they are really a real business, and I think it's also very hot right now. So based on like survey conducted by MIT and the BCG, so as you can see from here, like they did the survey of like more than 2,500 senior executives and other managers from 29 industry and 97 countries. So they found out actually 9 out of 10 like response. Let me check what's. Okay, so sorry, I'm going to answer the question later. So I'm just going to continue the presentation. So 9 out of 10, they believe AI is something real, and they say AI is a business opportunity. And 6 out of 10 of those companies, they have already claimed they made significant AI investments, and they have seen the impacts. Actually, this is very exciting and promising, which means the AI or data science is real. So there are huge potential there for like a job seekers or someone who want to transform their current job role into data science roles. So here for today's presentation, I want to really distinguish like both data science and AI, because they are different, but somehow I guess today I just want to cover both things at the same time. So when we talk about data science, actually, I just want to really divide this like terms into 2 words, like data and the science. So for data, I mean, it's very straightforward. So it's involved many things, but majorly like a data preparation. So the job related to maybe just data engineers, or even someone like responsible for SQL management and something similarly. So for the science, actually it's more focused on just modeling, algorithms, and something more like statistic analysis. So for this type of thing, the job there is more like a machine learning engineer or algorithm engineer. Depends on which company you're working in. So they have different like names there, but they're pretty similar like this. So together, like it's basically data science there. But I think rather than just when we talk about data science, we should always put the business there, because data science has no value at all if we do not have any business like values there. So that's also, I believe, like some of the company actually they have to kind of change their minds, because they only rely on data science rather than have a clear roadmap or strategy how to generate the business revenue or any values there. So, but if we talk about the business there, so there are type of like different application in multiple industries. And the job there are mostly like a business analyst or other more like a strategic level or operational level analysts. So for the interface among those 3 things, I think they were more like connected by software engineers like here and there. So eventually that's a whole like pipeline for the data science industry, I believe. So for the data scientist, so if you see an arrow like in the bottom there, so basically, based on my experience, I think a full stack data scientist cover basically everything up to like data, including the modeling and even reach into the business part. So it's a very all-inclusive like term. And also I think sometimes it's pretty weak because based on different industry or different company, you may have to change your like responsibility a little bit different, either lean to more like into data or more focus on science or more need to into like a business. But in general, basically the full stack data scientists cover the whole, I would say the whole ecosystem there. I will cover a little bit more detail like later. So then I guess you may be wondering like what is data scientist doing there because it covers so many things there. To be more specific, if we draw a diagram, so it's starting from like a configuration, data collection, even like a little bit more like a data mining and like a data extraction from database or from website or from any other third parties. And then future extraction, data verification, and then like machine learning resource management. Actually, this is very important, but especially for them like a big corporation, because they have the like a lot of resource there. So they do have specific like a pipeline or people to do that part of work. And then analysis tools and the process management tools and serving the infrastructure and the monitoring. But if you really focus on like if you really want to see like the diagram, you will see a very like small black box in the middle. That's like a machine learning code. So the box size is more based on the efforts like a company or people need to invest in every single like segment. So actually this pretty real, really like reflecting the real situation, which means the company, they spend on the modeling part is pretty relatively small compared to the whole like pipeline or ecosystem. So which means the data scientist is doing a lot of things, much more than just like model itself. Because a lot of people are worried about today, or I mean, recently say Google or Microsoft or Amazon, they have like a lot of like auto machine learning thing, like Tian also mentioned like from his slides, there are a lot of platforms that are doing something there. But also as Tian pointed out, actually that doesn't really change much for what data science will be doing. It's only just makes sense life much easier rather than replace the whole like positions, because the rest box is still there and actually it'll be much more relying on the data scientist. So which more coming from like what's the job there? So if we want to summarize that into one sentence, basically in my mind, like data scientist is really a group of people find a way to use the data to be useful. So this still sounds like weak, but actually that's exactly also the beauty of like working as a data scientist, because you have to work from different like business segments and working across different teams to really represent or to express your values there and prove this is real, this is useful in the company. But if we list the whole like workflows there in the data science area, so you may think about like what you will do if you're working in a company as a data scientist. Some of you may think maybe just figure out what's the best model and then just train the data and test the model. So actually, the most important thing is always not about the model at all. It's always starting from the data and from the problem you try to solve. So understanding the business, understanding the problems you're trying to solve always is the first step. And then spend more time understanding the data. So because there is a saying in the industry that if you want to be a machine learning expert, so you have to be a half expert in the domain you are working in. So for me, for example, I'm working in like a healthcare industry. So then I have to spend a lot of time to understanding the domain knowledge and the meaning of those like terms, not of like drug terms and a lot of like doctors are like handwriting thing. So without understanding those things, so we have no clue what the data means. So then if we just train the data, actually we have no idea what the data is doing. And even when we want to measure the data performance, or sorry, model performance, we don't know even how to explain that. So which means this is totally, I would say, junk, like waste of time, right? The company won't buy that. So after that, so it's like data importing and then data cleaning and then manipulation. So here we do not list the specific feature engineering, but actually we can put the feature engineering in this step specifically, because I think I will not even say that's one of the most steps. That's, in my opinion, one of the, I mean, that's just the most most important single thing, like feature engineering, which means like take the best things from the data you have, the patterns or the features or anything, you are able to throw into the model, right? And then that's the modeling part, like machine learning part. So finally followed by reporting, visualization, talk to your stakeholders, and to figure out if everything you are doing is matching their requirements. If there is some mismatch, actually we have to redo the whole thing, starting from the business understanding again, like try to understand where is the mismatch, how we can improve, where should we get the data again, and try the data there, and try the model also. So if you see, I mean, the efforts we need to do, the modeling is just very like small part there. So I believe that's what a data scientist is doing. So I'm going to describe the whole like working maybe their daily life using two like case studies from my previous companies. I won't talk too much technical detail because this is still like a very sensitive stage. So the product was not in the market yet, but I can still show some of the like high level pipeline to just prove the concept. So the first one is from C2Sense. They are developing a real-time gas monitoring system. So C2Sense is an MIT-based startup with a mission to transform the invisible gas information into visible knowledge. So the customer are able to take any actions based on what is able to see from the device. Supported by like both AI and Lalo technology. So this is different like from a materials department from MIT. So they did pretty good. So they secured the round A funding of around like 30 million in late 2019. So the workflow there is we want to have the input of chemical signals and the output as a gas concentration in real time for any remote device. So basically is you're able to check out check out your cell phone or iPad or computer to see any gas concentration or even gas type from anywhere in the whole world. So that's pretty, I mean, cool idea. The whole pipeline there is coming from always data collection and the data processing of those chemical signals into something the model is able to dealing with. So for example, we are starting collecting like only two data frames, but eventually we are generating a feature of over 30. So that's how we throw into the XG model and then host the model in the Docker image and run the visualization on the device. And that's how we are able to get the gas concentration. So for the case 2, that's the current project I'm working on. It's from Water's-Kluwer. It's a predictive clinic surveillance. So it's part of the efforts, AI efforts from the company, leveraging the machine learning techniques coupled with its own conventional clinical knowledge to enable predictive and prescriptive decision support in healthcare. Because the Water's-Kluwer Health is doing like a software AI solution to like hospitals and other organizations. So they need this thing to support the industry. The diagram on the left side basically show a very like simple process for anyone visit the hospital. For example, I guess I'm not quite sure if any of you had the experience visiting the US hospitals here. I mean, I had the chance when I was working in University of Florida. So it's pretty slow, I mean, process and not that efficient. Like always starting from admission, and then if we like want to get some treatment, so there are a lot of like tests based on your symptoms. The doctor will decide what's the test you're going to be like running on, And also based on those lab tests, and then there should be some like extra treatments there for some specific infection. And after a while, if the doctor believes the patient has a significant recovery, so then the patient will be discharged. But because of the bed size limit from many hospitals, also because of the huge lack of doctors even in the industry, so it's very hard even to get admitted into the hospital for someone, right? So for me, for example, if there is an example, I have very like small thing happening, but it takes like 3 days for me to even get admitted. But by that time, actually, I'm pretty already fully recovered. So which means there is a huge like waste of the resource or huge of potential. We can accelerate the whole process to really leverage the capability of the doctors to take care of the patients rather than like a contingent on different other things. So they cannot really use their efforts to take care of every single patient. So that's how the predictive clinic surveillance is doing for or used for, because this is based on collecting the historical patient's data or the historical staying data in the hospital. So then doing the real-time prediction of the possibility of infected by some specific disease. So if that risk possibility is high, so then we just send the patients like maybe in a more urgent or higher highest priority list into the doctors so they can take care of. For some or other patients, so if they have even they have similar symptoms, but based on the prediction, actually they are pretty low risk, which indicates highly possible it may not be that urgent, it's just caused by something else and easy to take care of. So then the doctor may just put those patients not that like equally important position. So then they can really spend their time taking care of the patients who really need the treatments, right? So that's the mission and goal there. So the whole pipeline also starting from collecting and gathering or even processing of any electric health record, which called EHR, and then going through feature engineering, data processing, normalization, or even standardization. So transform into feature we're able to use and run the, actually we're currently using the gradient boost tree model, and then hosted, wrapped by the Java API thing. So our customer are able to use this tool, which means whenever giving a single patient's information, we are able to share or give any prediction results for that single patient. So I think the whole thing is very cool, but it's also very challenging because of the data itself. I won't cover a lot of those things, but definitely I will mention this example again for my next slides. So based on those two cases, I think it's very similar to this workflow I just described. I hope you have the similar impression. But actually, I just want to mention one thing there is actually what is data scientists really doing? So are they really just doing the work following like those pipeline? For example, understand the business and then work very hard in the data, like in a private room, eventually share something out? Actually, probably not. Especially you want to really be a like very good data scientist. So based on my experience, I think we should keep something like seriously in mind because they're pretty important. So we need to make sure we are always talking to the right persons because data science is somehow like covering many things. So you are highly possible dealing with people from different parties and different people, they are taking the similar information maybe in different way. So eventually what you are doing, what you were told to do may not be the same what's the original design. So always talking to the right person to understand the scope, what's the deliverables, I think will be highly important and always keep in mind because it happened a lot to our team. Different people see the same information at the same time, but actually they have different understanding. And when they do things, actually the results is not always the same. So sometimes it's just a waste of a lot of time. Second thing is asking the right questions. This is also related to what's the goal of the whole project. What's the deliverable? What can we use? So what information can we use from available resource? And understanding your domain is also very critically important. So that's why I label those two, like asking right question and understanding your domain here. Like I label them to be more important than the others. I will explain a little bit later. So using the right tool is also important. This covered, like, I think, two things. So there are a lot of tools in the data science area. So if you really count them, I think there should be over 100 like platforms or resource you're able to use. Some of them pretty overlap with the others. So which means you don't need to use all of them. It's okay if you're not able to even hear any of them. But you have to be very skilled at some of the basic ones. So for example, Python is popular right now. So if you use Python to work in your project, so you should be very skilled at Python to know their libraries and those kind of tools, how you're able to take some actions for some of the tasks. And also for like NumPy or Pandas. So those things should be also very familiar with because that's so important in data science work if I use in Python. The last one is developing career continuously because there are a lot of things happening. I will not even say monthly, they're happening like daily. So some are similar than the others, but there are definitely some new things come out. So always keep in mind of the new things happening and like maintain yourself in a learning mode. So this is important to like for your work, also to maintain the strength to compete even for the future for your next job, right? So then now let's back to like those two things, like why asking the right questions. So this is basically the critical thinking. Understand your domain is just rather than understand the technique, you should also understand the industry you are dealing with. So this is very important to my current job because I'm working in healthcare. So actually, to be honest, when I joined the team, the first time I saw the features we're using, some of them I don't even know why we put them there. Probably because based on the model, the results showing like those are important. But from the like common sense, they totally should be removed because we should not really based on the prediction. Just based on the people's, let's say, like gender or something, or hospital location, right? Because this should not be that important. This even maybe like discrimination, I think. So we should maybe more rationalized to explore the feature. So asking the right questions is from the other example from my previous company. So even like after we work for half a year, very hard work, and we deliver something, but actually we realize there is a huge mismatch from the beginning requirements, just because there is a lot of miscommunication there. So as a data scientist, we have to be always asking the right things before we even take any actions. So I think those two are super, super important. So for some of the participants here, if you want to become a data scientist, especially if you do not have any technical background, I think it's totally fine. I think that's very common for the current industry and arena right now. Take me for example. So if you see the first slide, basically I had my like training in PhD in chemistry. So it has nothing to do with data science. So I still work here right now. So I like what I'm doing. So I think, so I even hear some other example, they work as a data scientist. Actually, their major is either in like literature or psychology or some other things. So it's not even STEM major, right? So, which means it's totally fine if you want to jump into this arena. But here are some, I guess, tips you can think about as a starter. So first one is just be flexible how you enter the field, because as I just said, it's totally fine. So is whatever you are right now, so you can always join the industry, share what's happening here. secondly, take relevant classes. So this relevant classes is much more than just technical ones. For example, Python or a model or auto ML or machine learning or those things, always starting from something much bigger. For example, communication classes, or presentation classes, or writing, or even like a debating, for example, right? Or anything, just learn. So anything will be useful here because, as I said, this is a full stack thing. So everything will be used eventually. There are a lot of resources like YouTube or Coursera and some other things. It's very easy and most of them are free. Then practice your communication. So it could be written, visual, or verbal, or any other type. So working on real data problems beyond Kaggle. So I think Kaggle is very interesting because a lot of people are starting from their career as data scientists since they starting a project in Kaggle, which is very great. But there is still a big difference between Kaggle and the real problems because for Kaggle, there people compete the performance of the model. So they spend a lot of time there, wrap their model, assemble their model, like many layers, very complicated. But for the real problems, actually, it's much different based on different industry, also based on the deployment requirements. We have different expectation of the model and how we handle the data. So we're always starting from some real problems, I think will be very useful. But starting from Kaggle, I mean, as a kind of a starter, which is fine. I would just recommend like work on some real problems because I had the chance to interview like multiple data scientists before. When I look at the, especially like the people just graduated from universities, when I look at the resume, there are a lot of like projects, but actually everyone is very similar than the others projects because they are course projects or Kaggle projects. So they did a very similar thing. And to me, it's very hard to really find out what's the difference from this person. So if someone really had like a real problem project, they did something. So it's very easy to just find out and just kind of call the attention is there. So I think that'd be pretty useful. Followed by like try to publish your work and get feedback. So you can, write down something in Medium or share your code in GitHub and ask for code review from people online or from your friends. Also, even like read the source code from the library, which will help you to understand like how people implement their code and design their structure. Go to the events like Confluence, meetups, and the hackathons are also super useful to either learn new things or meet new people. So I think those steps should be very straightforward and also I think easy to follow to start as a data scientist. That's actually exactly the same thing I followed, and also some of my close friends, they followed. So very, very interesting. So my currently co-worker, none of them is really from like data science program. So either they are from like a physics PhD program or chemistry or maybe mathematics or some other STEM major. We don't have a data science from psychology. That's unfortunate, but I guess we're going to hire one maybe in the future. So which means like everyone is following the same thing. So just be cool and just do it. So I think you'll be getting there because it works for other people, should also be working for you. So also people are worried about the future of the data science because actually this is something I worried about as well. I mean, for years ago, but actually right now I'm pretty convinced this is real something because other than the data science itself, I definitely see this is like a resolution. If I use like a word from the industry people talk about, which is like a digitalization. So basically transform everything, every single industry like into digitalization, automation, use a model to automate their labors and reduce their cost and also boost their performance. So I borrowed one like study from McKinsey company. They try, so I think this is pretty recent study. So they try to label the current AI adoption, based on the maturity for each industry, like labeled from high and from low to high, like in the vertical direction. And also the try to label the AI value are at stake based on their current market size and the pinpoints and the willingness to pay from the horizontal side. So if you see this, actually, basically you are able to put every industry there, but there's still a lot of opportunity to generate like AI value, high value for many other industries, because now it's totally empty, especially for those like high AI adoption parts. For some of the big players, for the market size, for example, healthcare and other industries, they are huge, but right now you see they are pretty still in the low level of the AI adoption and not that mature. I mean, this also makes sense. Probably also the banking. So banking here, they put in the medium because those industries are gigantic, and also they more focus on security. So they're a little bit more like hesitate to apply like a very fancy model, which is totally fine. But eventually, I believe they will be going through the whole digitalization and adapt the AI strategy like much more, I guess, yeah, much more extent. So which is, I think, which is cool because, so for example, take me for example, I'm currently working in healthcare industry. So my goal in the future, I probably will be, let's say 5 years maybe. Either if I still stay in the industry, I may want to be like a manager or let's say managing track in this industry, right? Or if I realize I like more technology, I probably will be more like a high level technical roles in some other industries, just kind of cover different scenarios. So that's kind of my current plan. So, but I believe there is a very beautiful path in the future for anyone who is doing data science and who is going to do data science in the future. So finally, I want to share something here. I think which is very encouraging. I borrowed this from one of my friends from my WeChat actually. So she posted this one in her WeChat like a post, which is said like, what if everything you're going through is preparing you for what you're asked for? So, and I think I know someone who is very struggling and maybe even suffering transition, I mean, around the transition from other track into data science or software engineer, because they're just kind of easier to like get a job, right? It's pretty tough. I mean, I went through this. I struggled as well, but I think I still, when I look back, I still think that's very good memory, and I'm really glad that I didn't really like change my mind, or I did not give up, because everything I was doing there actually is very helpful to what I'm doing right now. So I hope this will be helpful as well to some of you who want to go through the same process, even though you have low background or so. Yeah, so that's basically what I want to talk about under this kind of specific situation of the outbreak of, I mean, coronavirus season. I hope everyone is safe, and please stay connected with your family, your friends, and also if anything else, please connect me as well from LinkedIn. So I'll be happy to answer any more questions in the future. Thank you.
All right, can you hear me now? Okay, yeah. All right, so very appreciative of your effort and your great presentation. So in the interest of time, let's move to Liu Chen very quickly, and to make sure that I can find him.
Okay, so here's I am.
Okay,
can you hear me? Okay.
Yeah.
Perfect. Okay. Thank you very much, Tian and Junlin. I feel a lot of peer pressure. They did great presentation. So I'm going to have a relatively shorter one, maybe talking a little bit more focusing on the industrial trend that I have in my mind that I just want to share my idea with you guys, and also talking about like career development. What's like the next step after a data scientist, especially the managerial role. So I might want to start from like by introducing myself. So I got my bachelor degree from Nankai University in physics, and then PhD also in physics from Boston University. And after that, I moved to Houston to join an oil and gas company, doing seismic data imaging and pre-processing. And after that, I changed my industry into healthcare, like the medical device company, as a senior data scientist at Abiomed, where is a company producing like the pump that can be implanted in people's heart to get people's heart get recovered. And after 2 years, I've been moved to another industry in retail at TJX. So I suppose people know about TJ Maxx and Marshalls. This is like different brands under TJX. So I've been being a data science manager here for about 1.5 years. So basically, I changed a lot of different industries and see some changes in the data science industry, and want to share some of the thought with you. So the first thing I want to talk about is like the difference in different industry in data science. I really like the plot from Junlin. So the industry I've been staying in either oil and gas or medical device or retail is not like the high tech company. So I would say data science is not like the very core function of the industry. So there isn't like naturally a big team of data scientists. So usually it's like 1 or 2 data scientists or a small teams there. And data science is more like a supporting role. So probably to start from there, basically like if you work there, both you or your manager would have to do a lot of proof of concept and trying to make people make like the leadership to buy in data science, to see the value, and then to see what's the next step of it. So and for this kind of job positions, actually, I would say there's not a lot of like very hardcore data science skill set like a Spark or a lot of like really high advanced like a real-time prediction or something like that. It's more about like using the current well-established data science technology and then trying to see how do you use that in business. So it's a little bit different from the tech company that I know, because in tech company, you are actually just trying to like drive all the effort to the very edge, cutting edge of the technology, and trying to see what is the best you can do with the most updated technology. So that makes a little bit difference. So I would recommend that for the people who want to look for jobs right now. Maybe the big names like Google, Facebook is definitely like something that people always want to go to, but I mean also consider the traditional industry, for example, like retail or healthcare. So there are opportunities there, and the tech threshold there is not as like the bar there is not like a super high that you need to be like a computer science PhD or something like that. Also, I want to talk about like so when I joined the industry in like 2012, I find that not a lot of people are even using Python. Many of the people are using R, and also for machine learning thing is not as popular as it is right now. So so it seems like the technology stack is actually also improving with time. So so basically, so people have to get more knowledge in either the coding or machine learning to actually get a job. That makes the job hunting actually a little bit more difficult than 2 to 3 years if people have about the similar style, like a different level of the skill set in data science. So I would say definitely try more. That is what I want to give as a suggestion to job hunters. And also about like the future trend of the data science industry as a whole. My feeling is there could be different factors that could be changing over time. It could be data, to leadership's mindset, and talents. That's what I'm going to talk about. So as nowadays, there's more and more different ways to collect the data, and also data could be can be bought as like a document or something that you can just purchase from a third-party vendor. So there's more and more data that need to be analyzed or modeled. So there will be actually more job opportunities, to my understanding, especially when for some other like some specific industries, for example, like e-commerce, because you keep ingesting and digesting data, and there'll definitely be some positions needed for industries like that. And also too, maybe a couple of years ago, people usually just use like Excel to do data analysis, and then Tableau to do the data visualization. But right now, I think like more and more data analyst position or business analyst position is actually starting to use a Python or R, or even like a Spark or other this kind of other ones to analyze the data. So the tool itself is also kind of progressing. So definitely, I would say people should just keep learning the new tools and then be catching up with the time. And also, I want to talk about the leadership's mindset. So as I mentioned earlier, in the like the traditional industry, so people have to establish the excitement for the leadership to buy in. Data science can really bring business values to the company. So this is something probably either you or your boss could be trying really hard to. But eventually, if you get like the buy-in from the leadership, there will be more headcounts or resource to the group that will eventually benefit your career path. So to do that, I would say maybe it's not very important. It's not like the most important thing to build up some fancy machine learning tools like for example LSTM prediction of something. Even some relatively simpler but like a well-established model that with enough interpretative possibility could actually work better to get leadership's buy-in. And also right now there's a lot of like a new data science master program and in data science and also in business analytics and data analytics. So which makes the competition for job hunting also like the different the competitive level is also increasing. So that's so basically the demand and the supply all both improved. So my feeling is that the job hunters have to work really hard and then trying to learn the technology and get the business set to find the job in different industries. This is what my feeling is about the trend. And in the future, here's my thought. I think probably because right now there's a lot of data science toolbox that can just build in all the data science function there. You can just click to do all the pre-processing, visualization, analytics, or modeling all together. Even the parameter tuning is done just by one click, and then it could be deploy the model onto the cloud or doing fancy visualization. So my feeling is that like maybe 5 years from now, there will be a lot of cutting edge data scientists or core data scientists in big companies like Google or Facebook to build those kind of tools for the people in different industries to use that. But there might, the other companies, like the smaller company or traditional company, there might not be so many people in there building their own tools, because it will be maybe very cheap to just use whatever tool is already there. So probably there will be more domain knowledge required for the job, for people to gather the job and then doing great there. So it will be more like, instead of a data scientist, it's more like a business analyst with the skill set of some data science tool, knowing how to use that and how to interpret that. So that's my feeling about the future. So that is the first part I want to talk about, is the industry or my prediction. The next part will be the career path review. Mm-hmm. Okay, so as Junlin already also mentioned, there could be like 2 paths. If you want to move forward to the next level, one could be what we call IC, individual contributor. Another one is a managerial role. So in the individual contributor is more like you get promoted from data scientist to senior or principal or staff data scientist, and then just doing like more technical, being able to take more responsibility to deal with more complicated project, or like a more cutting edge technology. The scope of the project would also improve. And there could be other track, which is a managerial track. So basically you will start to have a reporting structure, have people reporting to you either as a supervisor or manager or director and above. I'm going to talk a little bit more about the managerial role. But what I want to say here in general is the promotion logic. So here's my understanding. Usually a company should have a established like a ladder for different roles. They should have their own job description. So basically a very simple question to a simple answer to the question of how to get promoted. My personal suggestion is go to see that ladder, see the job description for the next level, because the logic in the company to get people promoted is actually, if someone is starting to do the next level job with a very good deliverable and being there like steady for a short period of time, and this person could be promoted. So it's not like promote someone to the next level and then start to take responsibility of the next level. It's the opposite way. So you take responsibility from the next level, and then you've been staying there for a while, and then you got promoted to the correct level. So that's my understanding. Okay, so that's it. And the next step is what I want to talk about is the managerial track. So basically, so I know at the very beginning, when someone wants to decide to become like a manager in the future, it could be a little bit confusing. What could be the difference, or who should be a leader instead of an individual contributor? So so here, actually, I want to recommend something. I've downloaded an app called Geek Time, or 极客时间, and there's their class there. It's called 技术管理实战36讲. It's like 36 classes about tech leadership, and this is there's a lot of things I learned from there. And the most important thing is what I get is what should be the right person to be a manager. Like, who should be a manager? So some people think maybe I have to switch to the managerial role after several years of work, but actually that's not true. Especially in the tech company, there are two tracks that we discussed on parallel, and the individual track can actually go really deep. It could go even the like from principal to like a senior principal staff or senior staff. It can go really high. So if you don't feel you want to be like this managerial style, actually you can just be in the individual contributor. You still can get promotion and then get like a more valuable project. Maybe the leader is more like the person who want to take more responsibility to do like a multitask, a different project at the same time, to my mind, and also do feel that you want to have like a bigger scope, understand like how something could go like a full deck from the very beginning, from the roadmap phase to be a product, and then how do you actually convince the leadership this is something that the company needs, and then you want to kind of really put that into in the production pipeline. So that also gives you like a feeling of accomplishment and of growth. So this could be like the reason why people want to be a manager. Actually, some people think maybe manager makes more money, or it's being cool. Eventually, after really feeling the tedious everyday work, or checking on like a Glassdoor, it eventually seems to be untrue. So it's really about someone who wants to kind of develop the scope, or like different style of working that need to be develop themselves into the managerial role. So here's my understanding about like what to improve if someone want to be a manager. So I would say hard skill, soft skills, and mindset. So hard skills is definitely something that the two presenters already mentioned a lot about, the technology part that you need to understand, and also the business part that you have to understand, like how and why the data science tools could be used to solve the business problems, and how do you ask the problem, the question, and how to answer those. So both of them could be considered and can be considered and hard skills. That's my understanding. And also for the soft skills, I would say mainly about storytelling and communication. Storytelling, the two presenters already discussed about it. So basically, you don't want to produce an equation, right? You want to tell the business leader that why we are doing this, how we are doing this, and how much we could bring to the business. So this is definitely a story you have to get buy-in from your boss and even above. And also communication. So my feeling is that so like when people get promoted or being on the managerial track, it's like naturally more communication that is needed, and you have to keep discussing with boss about like especially how you are, like why you are doing that instead of how you are doing that, because you need to kind of figure out by yourself for that part. But it's more about like why you are doing that, or like big picture wise, how does that work could be fitted into the bigger picture. And also I want to talk about the mindset. There could also be some kind of a change when people get into the managerial track. So it could be different attitudes towards technology, because for leaders, technology is not the purpose, but the tool. So when you evaluate whether one tool could be better than another one, it may not be as simple as just compare the accuracy of the two things. It may be the cost, or how long does it take to make the development, or interpretability of those two different tools. So it's really a different angle of point to evaluate or judge different technology. Instead of making that as something that we can like how to make that into real life, but about how and when to use that. So that is what I have about like the skill set wise, how people could improve to kind of moving towards the managerial track. And the last thing I want to talk about is actually how to start to build up the skill set towards that track. So I would say start to build leadership skills by thinking as a leader. So the class that I just recommended could tell you something about that. Actually, as a leader, how do you think of an individual project or interaction between different projects? Or even if you are listening to talks from other team members of your team, you may also think about that as a leader. And if I control that project, what should I improve? What should be the bottleneck of that project? And then what do I do to solve that? Something like that. And also kind of from resource perspective, how do you allocate the resource of the group to put more effort or money into different projects? So again, to think about all these projects as a leader before you become the leader. And the second thing I would say is trying to take more responsibility, more than what you deserve. So probably when I was a data scientist or senior data scientist, I'm trying to mentor interns or co-ops, and then work with the intern and co-op to kind of build up my skill set in leadership, and also be able to work with people and then to lead projects. This is also like a valuable asset to myself that I find very helpful. And then the last thing, but not least, is talk to the leaders around. So I remember when I actually just become a manager, I also talked to Daniel, and then got a lot of very precious suggestion from him. Thank you very much. So basically, you must have a lot of friends who's already been that track. So my suggestion is to talk to them, trying to understand what they suggest you to do, what's their pain point, what they do they worry about, and then what is like the logic of being a leader, something like that. Okay, so that's probably that's what I want to talk today. I'm going to hand it over back to Daniel. If you have any question, please feel free to ask later. Okay, thank you.
Okay, thank you, Daniel.
All right, thank you. Thank you. Can you hear me now?
Thank you, Chan. I can hear you. Yeah, thank you all.
Okay, perfect. So I'm going to just skip through this. Let me get to the next page right now. So this is a lot of Q&A that we put together from your survey question. And in essence, when you register, this is we ask you one question, and this is a consolidation of all the questions we have. So kind of ranging from career path, data science day-to-day, hard skill, soft skill, intro of and future of data science. So I'm just going to ask maybe one question from each, and then feel free to, so Xiatian, Junling, and also Liu Chen, if you don't mind, maybe just kind of look through the one question and maybe just pick one to answer. I know we're in the interest of time, we also want to save some time for participants to ask questions directly. So the first part about the career path, I think Liu Chen already kind of touched on, actually talked quite a bit about how to get promoted, right? You want to get to the next level by looking at job description for next level and see if you already met it. So that's perfectly making sense. But what does the career progression look like after manager? Like, so where do you take from there? So, what are some of the prospective career paths where you can go up or maybe go sideways into a different area in the function? So Liu Chen, do you mind just maybe address that a little bit?
Thank you, Daniel. So right now I'm also trying to kind of answer that question for myself, right? Because so the first part could be like, what's after manager? So my feeling is that manager is more like you take the project and then you complete it with your team, right? And then the next level will be more like, so please correct me, my feeling is like trying to allocate the resource and trying to really build in what I call like a business pipeline that how do you get the project in, how do you get the project out, how do you get the business leader to buy in, and then to give more resource. And when you get resource, how do you allocate to either hire someone or get a contractor? How do you use this to decide like where is the direction your team should be going on? So that's my understanding about the director level, but definitely Daniel, you know much better than I do for that one. And for the set track that you mentioned, maybe what could we do else? So I talk about individual contributor role, like being senior staff or principal and keep moving up, taking more and more challenging and complicated project. And that could be more like that, probably working with more people instead of having those people reporting to you. That's my understanding about individual contributor role and managerial that also talk about. There could be other track, could be, for example, like the product manager, which let people in that field should have, my feeling is should have more skill set of understanding or finding out the pain point of a product, and then how do you starting from brainstorm a product to carry it over all the way through to the end. So I don't know too much about that, but product manager could be definitely one of another track. And there could be a project manager. That could be another thing that is neither individual contributor nor managerial role, but it's more like controlling the project or kind of monitoring the project from the beginning to the end, trying to set up milestone and then also allocate resource within the project. So that's, I hope that answered the questions about the side roles and also like what's about manager. Is there anything else you want to add in, Daniel?
I think this is very pretty much like, you know, what I have in mind too. So one is moving up. You know, you become the director VP. You know, I guess the top position at executive level for data science is probably some places have Chief Analytics Officer, so CAO. Not a very great name for Chinese, but it's a title that's if you're running the, you know, maybe potentially Chief Data Officer, right? That might be the career aspiration for a lot of data scientists. You want to become the #1 spot that makes data strategy and also use those to drive the executive vision. So maybe that's where, if you're continuing on that, on building on your skill set, your managerial skills, as well as your team management, resource allocation, and executive vision, maybe that's where you'll be heading to. That's my guess. And I've seen examples in various places where, like you mentioned, if you are familiar with the data, but also familiar with the business, you know, you can start maybe sidetracking into the business domain. So we have a person also from Wharton a couple of years ago from my team that she was running the analytics for marketing, and when there is a retention marketing position open that the team is about to expand, you know, she became the director of retention marketing, you know, for the company. So it is also opportunity in like a lateral plus promotion, you know, into, you know, the business area that you're managing, because data is just a tool, right? If you know the tool, but if you also know the business, that might be the direction you can also take too. Owning the P&L, owning the business units, potentially for data scientists. So anything you want to add, Liu Chen or Xiatian or Junling on this?
Nope.
Okay. I'm going to move on to the next question. So data science day-to-day, I think all of you touched on that a little bit, but one thing I want to kind of focus on is, what is your split of time? So I guess it's different, you know, among like finance, retail, and biopharmaceutical. But can you just kind of talk about, like, you know, is it roughly 60% coding, you know, 30% meetings, 10% everything else, or what does that split look like? So, Junling, Liu Chen.
Yeah, Daniel, maybe I can start.
Okay. Perfect.
So I think for me, I probably spend like a 30 time for meeting, I think, which is surprisingly too much, I guess. So 30 for meeting, maybe I would say another 30 for model, like a related coding, another I guess the rest of the time, also for coding or coding management, or something else, but it's more for data or either cleaning or management, or like a plotting visualization thing. Yeah. That's it.
Daniel, you're online?
I guess I just lost some connection. So did you guys hear my answers or?
After you say that's it, the voice is gone. Something
Okay.
missing?
No, I don't think we missed anything. Yeah.
Daniel, you can carry on.
I think maybe we can just move to the next question. So what do I need outside R and Python, SQL, and number one tool of your choice? I think, personally, I think it really depends on what kind of data scientist you're looking at. So I know like some kind of data scientists like in Facebook, Airbnb, actually you will do the job more like a data analyst or business analyst. You will not do any modelings. So basically, maybe you will just use the SQL or Tableaus. So in this case, maybe I think the number one tool of your choice will be some kind of the visualization tool. But in terms of some other data scientists, for example, or I think maybe the Spark is the number one tool of my choice, because currently I see more and more companies will move to Spark, and everything will go to the cloud. Yes, you can code like use the Spark and the Python together, and maybe sometimes if you want to use some deep learning models, you have to learn like the PyTorch or TensorFlow, some kind of these frameworks. I think it will be very useful. That's it. Thank you.
All right, thank you. What about, I mean, probably R and Python are probably number one most needed skills. I also think people start using like, I guess it's kind of going back to Junling's presentation earlier, people call data scientists differently. So at Facebook, data scientists are essentially business analysts. At certain other places, data scientists are machine learning engineers. So I guess it all depends on what position at what company that we're looking at. So outside of Spark, Junling and Liu Chen, do you have any other recommendations? Xiaotian mentioned Spark, but is there any other hard skill that's recommended for you to kind of touch on that you use on day to day?
So I actually just, my team has been just using R, Python, SQL plus Tableau. That's all we have. And to my understanding, some people might use like Scala or like some non-SQL database like MongoDB. That's what I know the industry is about, but that's not something that I or my team have been doing.
Yeah, I think like a follow-up thing. I do believe like a Python, maybe plus SQL, or sometimes like a Python or R. This should be sufficient to even just get the thing started. Visualization and big data like a processing tool like Spark, as Tian mentioned, I think they are very useful. So for example, our team now is like I didn't use Spark before, so now we also like need to learn how to use it, because we want to handle the data in large scale processing in cloud. So, but I mean, we can start from Python there, and I believe that should be sufficient. But for different teams, like as Liu mentioned, they probably have other specific tools as well. But we probably cannot prepare all of them at once. But that's still fine. When you get into the team, I think you can learn while you work. So that's totally acceptable. Thank you.
Okay, perfect. Thank you so much. And then I think just want to touch on that. So outside of Python, R, SQL, and Tableau, some of my data scientists, they also are heavily invest their time in Excel and PowerPoint, because at the end of the day, they're presenting their finding back to the client. So I guess that brings us to the next one, the soft skill. I think presentation, storytelling, communication, business acumen, those are all important. So what are something that make your job successfully outside of the hard skill that we talked about? I think some of you mentioned it. But I think this might be an opportunity maybe to kind of further emphasize or maybe supplement what you just talked about. Liu Chen, do you want to start first?
Sure. Yeah. So basically, I try different industry, different companies, and different bosses. And my current boss and my previous boss, they are both with a MBA background, not like tech plus MBA, but purely from business field. So they are not quite familiar with those machine learning things or even some of the mathematical tools. So my feeling the most challenging thing, or like what I always have to spend a lot of effort to is to use a layman term to explain technologies. For example, what K-means stand for, how does like LSTM work, how to kind of using very like a commonly used language, not using those technology terms to get them understand, to let them understand technology, but don't feel like they have to really learn the math behind it. So so that's my feeling, how to use layman term to talk about technology.
All right. What about you two, Junie and then CYPN?
Maybe I can take the next step. So so for me, I think also I mentioned similar opinions in my slides. So communication, specifically like a presentation or oral presentation or even writing presentation or the poster or something, I think they are super helpful, but definitely they are not like the first step necessary thing you have to have, because a lot of people they jump into, especially let's say like Asia background or Chinese background students, when they join the data science, they more like have STEM background, so they have like technical skill, right? So we are kind of lack of the soft skills as we put them there. So I think that's just the situation. But I think that's pretty easy thing we can improve, because as long as you join the company, you have to kind of define your performance goals per year, and also you have to define your development goals like every year. So which cover like the area where you want to improve and how much you want to improve. So sometimes the corporation or like your team even pay for those costs. So including, for example, for me, so for year 2020, so like my development goals were including like both machine learning thing. Also, another part is like improve my soft skills in communication. So basically, I'm going to find a speech coach, try to teach me how to give like better presentation there. So because this is very helpful to either like convince your boss or your stakeholder the impact of the presentation or of your project, right? And also will be super helpful for your like a future career if you switch to different company or into different roles. So I think they are important and they are needed for your job. But I mean, for the new graduate students, I mean, you don't have all of those things to join, because I mean that's kind of just impossible, right? So for the MBAs needed, I mean MBA that needed in data science for some specific role is more like either for operation part, like I mean Daniel has a similar background, right? So they kind of start from the very high level to design the strategy and then work with this technology people to move forward their project. But I mean MBA is very like small number in this data science, just because I mean it's very expensive to train one MBA. So I think it's good to have them, and especially if you have like a master degree in tech, you probably will want to get MBA in the future, just because it's helpful for your career as well. I mean, yeah, that's basically how I say this. Thank you.
All right.
Okay.
Xiaotian, anything to add? Yeah, thank you.
Yeah, I just want to share my experience about that communication part. Actually, I'm still in my very early stage of my career, so I started to lead some project and manage 1 or 2 people last year, and I feel, well, it's something like I built a very good model, but when I want to allocate some resources, when I want to communicate this model with some other teams, well, it's not an easy job. For example, as a credit risk team, we build some loss models, and actually it's a key component for the pricing model. So we will communicate is with the pricing team, but actually they say, no, we cannot use this model. We don't have this attribute. And at the different stage of the loan application step, we cannot use this, we cannot use that. There are many pushbacks there. And at first I feel it's a little confused, a little frustrated. Then my manager just gave me some advice, just talk more and know how to communicate with different type of people. For example, I know in the credit risk team, like in the bank or in the data science team, there are many Chinese there, and many in the lunch, you will eat with these Chinese colleagues and talk with them. Actually, sometimes you could jump out of this small group, talk with different people, many just in different groups. Maybe you don't know them, just talk with them, and then just practice your communication skills. And sometimes so for example, like you have a few hours available, maybe just call different peoples and then just talk with them, just chat with them. It just help you to understand how different people think, what kind of things they really care about. Yeah, just something like this. I mean, just talk more to practice your communication skills. Yeah.
Yeah, really appreciate it. So I think Liu Chen probably addressed at one point. So I think Liu Chen had an MBA for data science. I'm also pursuing my MBA right now. I haven't graduated yet. I think this is the question came from, I think, someone that mentioned in the chat today, and also we collected that information from the I think just a couple of people asking the same question. What is MBA required for data science progression? I think I think there's a lot more PhDs than MBAs in data science. But at the same time, I think for career progression, it doesn't matter if it's data science or something else. I think if you want to learn more about the business or why you're supporting the business, and especially if you're a cross-functioning DS, which means that you are supporting finance, accounting, like if you're in the corporate, right, you're supporting all different firms, all different kind of organizations within the company, or if you're on the consulting arm of the business where you are working with different people in the industry, I think that's where MBA becomes extremely valuable. There's all different tracks within MBA. You can do MBA in marketing, MBA in operations, but at the end of the day, your year one of your MBA is always going to be general management, finance, accounting, all the basics, the fundamentals of the business. And then I think that learning how to speak their language when talking to the CFO, when talking to finance firms, and also learning how to speak their language when speak to the operations folks, that part is hugely valuable. So I think this is just a way for you to get in the right mindset to speaking to, to your client, people who you're supporting. But of course, if you're a machine learning engineer that just focus purely on the modeling aspect of the business which you already understood, then there might not be a need for MBA. So I think that's just my personal take. And Liu Chen, if you have anything else to add, I know you have an EMBA as well. Feel free to chime in before we move to the next one.
Okay, yeah, thanks, Daniel. So yeah, I totally agree with what you just mentioned. I think that's very helpful. So my feeling is that it might be a good. So if I could choose, I would say maybe becoming a data scientist to work for several years, and then if someone really want to be on the managerial track, and then kind of hitting some glass ceiling, so that could be the time for the MBA. Otherwise, I think like a master in like a STEM majors or a PhD should be good enough.
All right, thank you so much, Liu Chen.
Only personal, I guess. Okay.
Okay, all right, we appreciate it. I think that at one point we can probably have a separate seminar about management in data science, or maybe across all industries, and is MBA needed or not needed. We can have a separate discussion topic, a more in-depth discussion, with the speakers. And so moving on to the next one, the entry-level question. So there are a lot of students in this room that had no idea what data science looked like, but everyone wants to get into data science. So there's a two-part question with this. So a lot of people do not have a stats or computer science background, right? I think I've seen questions from the survey where someone was asking, I'm in EE, I'm electrical engineering right now, how do I get in, right? How long does it take for me to learn from learning to mastering, right? And also with everything happening in the data science now, with AutoML from Google, and also CYPN mentioned H2O.ai, where it does feature engineering, automatically, and also with SageMaker from AWS, all those automatic, validation, model selection tool sets out there. What is the future outlook? Like, how would you be successful in data science, and how would you crack into data science field, especially knowing that all of those fancy tools are out there that automate 100% or maybe 90% things you learn from school to start off with data science? I think that's also maybe a question that's relevant. So maybe just feel free to address any part of those two-part questions, and then who wants to go first? I'm gonna mute.
So hi Daniel, maybe I can get started first. Able to hear me?
Yes, we can hear you.
Okay.
Yes, we can hear you.
So, I originally do not have any CS background, I guess, until I take CS classes. But I know friends, they do not have CS background at all, but they still did a pretty good job in data science, like as a senior data scientist or even lead data scientist in some bigger companies. It's just very easy. Just try to learn Python first, because and then learn some machine learning classes from like online tools, either YouTube or Coursera. Based on his background, I probably think he spent 2 months there, full-time 2 months, like studying Python and also machine learning classes before he's able to get some interviews and then get some of the offers. So I believe, he did this like 2 years ago. I'm not quite sure if that's still the right number, like a timeline or effort you need to prepare. But I do believe starting from Python, know how to use that effectively, and also understand the basic thing in the modeling. You don't need to know everything, but some basic thing, able to answer the interview questions, starting from maybe a smaller size company, and even from the co-op, getting some sense from the real data problem, and then switch to some maybe dream jobs or in bigger company. So I think that seems a good pathway there, and because it worked with some other people. So for the future of the DS, I think there are a lot of as Daniel mentioned, there are a lot of fancy tools or platforms come out, because people want to, the big company, right? They want to make money, so they put everything there. They try to put this AI thing under their territory and make it like a service, so other smaller company is able to use or subscribe. So the smaller company, they don't need to spend money hiring a huge data team to handle their problem, because their problem might be just much simpler or relatively smaller size. So they can just subscribe to the service. So I think that's kind of the AutoML or other things from Amazon or Google. So that's helpful, but I don't think that will replace the industry or the data science as a whole, because that's just a tool. So the tool is only useful in the hands of the right person, right? So it's just bringing more convenience when people are trying to create more complicated projects and improve their effectiveness or efficiency. But I don't think it won't change anything that much. So that being said, being in the industry, try to learn more things, strengthen the competency should be fine, I think. Yeah. Thanks.
Perfect. Thank you so much, Xia Tian, and then Liu Shen, anything to add?
Yeah, I agree with Junling. If you want to get into the data science, Python will be the first option to learn, and also the SQL. Yeah, SQL is very simple. Maybe just 1 or 2 weeks, you'll be very familiar with the SQL queries. And also another suggestion is just find, if you're looking for some jobs, for example, in the summer or in September, October, just first you can just search data scientist, like in Boston, New York, and find maybe 20 or 30 job descriptions, and also find the techniques, the models they need, the softwares they are required for, and then just you can get a sense of what kind of techniques that the industry really need, and then just start to learn these models and also learn these techniques. And at first, I think maybe I believe 2 or 3 months are enough. And also sometimes, I know in order to prepare the data science interview, you have to learn many things, like some companies, some tech companies will even have some questions about the codings. If you just have 2 or 3 months, my recommendation is to not worry about this part. Just first focus on some data science, data manipulation skills in Python and SQL, and the basic modeling skills in machine learning, or some basic models in deep learning. Yeah, that's it.
All right, thank you, Xiaodian. Liu Chen, anything else to add?
Sure, yeah. So I really agree with what Tian and Junling mentioned about SQL and Python, and I just want to add a little bit of the machine learning. So there's a very famous class, I suppose maybe half of the audience already took, which is Andrew Nass machine learning on Coursera. This is really a good class for introducing some of the concepts of machine learning. So I strongly recommend that if you haven't taken that yet. And for the and by the way, could I kind of a verbally post a advertisement of our co-op position, Daniel?
Of course. Yeah, okay. If you have positions open, I forgot to mention this. Yeah, Xiaodian and then Junling, you too. If you have position open in your firm, please let us know. Or you can type in here in the chat, or you can put on the WeChat group we have. But yeah, feel free to do that. You're more than welcome to.
Sure. Yeah. So actually, we have a co-op position starting from this July to the end of December. So we are looking for like student who would like to join us for half a year, and then do the co-op on-site at Framingham. So if anyone is interested in this data science co-op, please feel free to send your resume to me. Maybe by the end of the day, because we are kind of just making the final list of the on-site interview. So Daniel, maybe at the end, could you mind to share my my email address is on my introduction page, or send that in the group? Okay, thank you very much.
Of course, yeah.
Thank you.
All right, really appreciate it. I think this is pretty much the main part of the major part of it. I will open up for questions now. But before I continue, I want to emphasize 2 things. So first of all, if you haven't done so already, please scan the top right form of the on the side of the corner of the slide. So that's our public WeChat account. So we have all the events. This is data science. In the future, we might have more something along the line of CFAs, in the finance firms. There will be talks about the healthcare. There will be a talk about on the management consulting. So, or maybe should I get MBA or not? Maybe potentially that's another topic too. So in any case, if you haven't done so already, please scan the top right QR code. Again, we're a nonprofit 501c3 group, so we do not make money off classes. We just basically, sometimes take donations, and we don't want to contribute. That's totally fine. And we also have Dragon Ball team. CYPN has been established for about 10 years now, and we have a lot of events ranging from seminars like this all the way down to ski trips and barbecues, and also we have clubbing events or dance parties. And most importantly, we have a Dragon Ball team that's fairly active in the greater Boston area. So if you're in the area, if you want to also do a little exercise, a little team building, feel free to talk to Xiaodian and then Junling, and those two are the members of the team. I'm also one of the rowing member as well, the steer of the team. So yeah, feel free to do that. We also have a WeChat group for this session today. So like, if you have any questions, you want to come talk to us, join us. Please check your email. Like how you got into this session with a Zoom link. There should also be a QR code to scan the QR code and get into a WeChat group. They can communicate publicly in the chat after we complete the session on Zoom. So you can talk to the speakers or me or people in the CYPN directly. And also last but not least, if you're interested in become volunteer and work with us to bring more sessions like this, free for all, please let us know. We're always looking for people that can help us to help yourself, but also help the rest of the people as well. All right, so now let's turn to the question for the audience. I think there's some chat question we have earlier. So you have two options. You can either take the mic and then speak, but please be sure to turn off the mic afterwards, or just type if you don't feel comfortable speaking. Just type in the chat message, and we'll try to moderate it. Okay, who wants to start first?
Anyone who have questions, you can turn on your microphone or to leave your comments in the chat group, in the chat board. Yeah, just be in order.
I'm going to just, I think there's a question from earlier. So maybe, well, before anyone else like volunteer, so for you, Xiaojian, specifically, like why are banks still using logistic regression as opposed to any non-parametric models like trees or neural network and such? Just kind of like a little specific, but and while you answer, we try to see if anyone else can start raising questions.
Okay, I think the most important reason is the bank needs the interpretabilities in this kind of model, because as I mentioned before, if we reject some customer, we have to provide the reject reasons. So if you use a logistic regression model, it's more easier to create some rejection reason just from the coefficient of each attribute. And currently, I see more and more models like the bankruptcy model, fraud detection model. They are moving to some tree-based model, deep learning models, and we will also use some black box machine learning interpretation skills to interpret these attributes. Basically, they will use some local explanation method to explain these machine learning models. So even though logistic regression is widely used, but there is still the trend that moving to some other machine learning and deep learning models. Yeah.
Okay, thank you so much. I think someone else was asking, like Michael was asking, other than scorecard, is there any other ML practice in the production? So do you guys do something outside of the scorecard?
Yes. Like I mentioned, like the fraud detection model, it's because it's very important to capture the customer behavior in the short time period. Let's say the attributes were only updated, let's say, in each month. But if I know it, then I would just open maybe hundreds of credit cards or personal loans in the last 2 weeks. And then the attributes will not capture my performance. So in that case, the first we have to get more and more additional data. So basically means like your phone bills, something else, and electricity bills or some other attributes, or basically we have to get more data. And in that case, maybe logistic regression model is not a good candidate model for this kind of attributes, and we will use more and more tree-based models. And I know many people, like in the cattle competition, many people will just use the attributes. The performance is very good and it's very fast. So we will also use this kind of tree-based model in some fraud detections, or in like how to predict some defined loan status or bankruptcy models, something like this.
Okay. And the next question is really kind of generic. So what region in the US do you think is best for data science to find a job and to living? I guess, well, the three speakers are from Boston, so the answer might be a little biased, but let's start from there. Junling and Xiaqian.
Yeah. So I can start first. So I think data science. So in the future, it might be part of the digitalization for every single industry. But at this moment, I think it's still very related to high-tech companies. So which means that the job where the software engineer or some other technical role coming from might be pretty much the similar area. The data science might be more coming from. So I would say like California Bay Area, Seattle, Boston. I think those three maybe still like top three area, I would imagine, in the US. Is that the physical area you guys more asking the industry? So but that's how I see this. Thank you.
So if we talk about the cross different industry, I would say I would totally agree. Like San Francisco is definitely number one, without any doubt, and number two could be several like Seattle or Los Angeles or New York, or Chicago or Boston. So those are the five that I think could be quite similar to each other. But San Francisco is definitely one if we are just talking about work instead of life or anything else.
Oh yeah, so I think as mentioned just by so I think one more thing I want to mention is if you are interested in financial sector positions, New York City might be a very good place. So they are hiring a lot of like quantitative related positions, and I think their pay is very surprisingly good. But I think the requirements is also extremely competitive. So you have to be very strong in a lot of like quantitative skill sets. But that's still I guess possible to prepare. So because I know someone who has like physics background and they spend probably half a year to prepare, and then they got hired in one of the biggest like venture capital companies, and they pay a lot.
Yeah, I think just to add on to that, I mean, obviously SF is always number one spot, but New York City, surprisingly, is also booming pretty quickly with the ample job opportunities in the tri-state area. So there's a lot of opportunities on Manhattan Beach. I know Disney is expanding, Google is expanding. A lot of finance firms is also looking for data science. And that might be an area that's traditionally kind of going under the surface, but I think that's where maybe the next opportunity is at. And also related to that, Boston is a great place to start your career too. There are some recent layoffs from Wayfair. I know a lot of data scientists were laid off, and also Expedia had a recent layoff too. I think that's kind of related back to someone's question earlier. But if you have industry experience, it's really not difficult for you, especially where you have H-1B, to transfer to a different firm with that skill set. So yes, there has been some layoff in the past. I think when someone else was asking the question, but I don't think it's a trend. I think data scientist is not going away. And then if you are laid off because your company's performance, there are always opportunities for you to go elsewhere. So that's not a concern. I think someone else was also asking the class name for Python that Liu Chen just recommended. I try to answer that, but I'm not sure if I got it right. So Liu Chen, can you just talk about the Python class that you just mentioned? Is that from Andrew Wu's machine learning?
Oh, hi. Sorry, Daniel. Actually, I mentioned the machine learning class, not the Python one. So okay. I think it's already been answered there with the detail of the class. For Python, I didn't say anything. Okay, thanks.
Got it. Yeah. I think one resource I like to use is it's called DataCamp. So let me just type it out here. Datacamp.com. And it's mostly free. I mean, if you want to pay for it, it's like $30 a month or something, or maybe $200 for the whole year. So it's fairly cheap, and also it gives you enough training on the Python, how to get things started. They're really not worth it to spend a lot of money to take the Python class. I think that can be self-taught. Just follow those classes, take some Coursera, take some DataCamp classes, and you don't need to attend school just to take Python. I know there's a lot of training camps out there. Maybe there's things you can do with them on the machine learning side, but in terms of programming, I think self-taught might be the most efficient way to do business, or to start getting to the business. Any comments on that, or any suggestions, or maybe something you disagree from audience too?
I mean, I strongly agree with just Daniel what he said. I think Python is very self-explanatory, and it's very easy to just understand what the language it is about. So I think it's totally reasonable to self-learn, and so try to go through the the libraries and read the source code after you have the basic sense of the language syntax, and then I think after probably 1 month you're able to write very smooth Python code, and then try to learn what's a beautiful code look like. So make it a little bit more more like a production code. But that's kind of step by step. But I totally agree. It could be self-learned.
Okay. And I think that someone else was also asking the questions. There's a lot of PhDs from science engineering. I think we have 2 here, right, from physics and chemistry that get into the data science. But then most people are still working the traditional ML technique. I'm guessing that's like non-parametric, like trees, like simple trees, and also maybe XGBoost and such. But I guess the question here is it easy for the PhD to break into the natural language processing or computer vision, NLP or CV, using deep learning method? So that's more of a question for the speakers. What is your what have you seen? A lot of people are doing those kind of work, like the true machine learning engineers, or is it most people are still using traditional techniques? And is there a benefit coming from a PhD?
So I think let me take first because that's something I'll be thinking for a while because I want to consider that as one of my future career. So I think the question is absolutely right. So right now, a lot of data scientists that are coming from PhDs. I guess the reason is pretty straightforward because they do have multiple years of a very professional training in how to do the critical thinking and proposing different ideas, and then to design the experiments to either prove or disapprove those assumptions and finally deliver something. So that's exactly the data science is working, the working flow look like. But as you mentioned in the question, that's still more try to solve the problem, how to use a tool to get the insights and solve the problem in a business way. But for some of the core machine learning model part, I think still I think that strongly rely on people with very strong technical background. Either they're coming from a PhD program in machine learning, or at least statistics or biostatistic, I guess, because that's how the model was built on, right? So those guys are working very hard to build those models, and they publish the results, so other people are able to understand and then use them. So I guess it's still possible for people to move into those areas. So if you're very strong in technique side, and then you're interested in to developing some fancy model, so that's definitely possible. So I know people who work in some a small company for just regular data scientists, and then because they are learning a lot of things when they work, so they eventually go to Google to just focus on some projects in Google Brain. So that's definitely the pure modeling. So that's just possible. Depends on if that's your interest and how much time you spend there. Yeah.
All right. Anything to add? Xiaotian, you don't have to, but just checking to see if you have anything to want to chime in.
Okay, yeah, because I feel it really depends on, so for example, in the bank, what kind of data do I have, or can I use the NLP or CV techniques on their data? Because as a bank, I think maybe we're more easy to get some audio data. So for example, many people were calling the bank and they will have some problems, and maybe the bank will solve these problems. Maybe they're happy, they're not happy. So I remember in 2018, I did have a project about NLP. I used NLP techniques to do some sentiment analysis, just very simple model, run model in Python, to analyze if their customer is happy or not happy about each conversation, something like this. But finally, we do not find it will add too much benefit to our business. So finally, it's just something like just explore the NLP technique on our existing data. So I think it will always happen in many industries. There are some fancy techniques and you try it, but sometimes you feel, well, you will not see too much benefit from this technique. So that is just my experience.
Okay, perfect.
Okay, Daniel, may I follow up very quick? So
yeah.
To that question, I guess if I misinterpret the question, is asking what is asking for. If it's asking about like if it's necessary to really use those NLP and CV or deep learning methods to solve some problems, I think my answer is I mean that's really what Tian is answering. So it really depends on what's your task and what your project is for, because so I mean we have take me on our projects, for example. I'm working in healthcare, so the security and like how to explain the model is definitely the highest priority before we deliver products, right? Rather than even the model performance. So we always start from a simple one, but definitely it should be reasonable, like well performed, than very complicated one. For two things, one is it's just too much to explain the too much technical detail to the stakeholder. So they want to buy it because they care about like if that's justified, if it's justifiable, right? Second thing is we need to always keep in mind every single model will be used in the product. So what's the requirements or limits for deployment? Because sometimes the complicated model cannot be even deployed in their device or in their system. So we have to sacrifice to use relative like smaller size or a relative simpler model. So I guess back to the other point. So for the modeling, what modeling to solve what problems actually is not even the model problem. I think it's still the feature problem. As long as the feature is good enough, so I think even a very like a simple model can do the same thing. So that's, I mean, how I see the thing. Thanks.
Yeah, thanks for bringing that up. I think that's kind of the next question. Related to the next question, right? Features are important. This is from Tony. Features are important in the model. The feature is significant in the model, but the business partner do not think it makes sense. Who will make the final decision, the modeler or the business partner? I think that Trini already mentioned that answer, but Xiaotian and then Youchen, do you guys have anything to pitch in? So who makes the call on features?
Okay, so I would say it's really dependent on the correlation. Is this like who's driving the business? It's really dependent on different structure of the company. For example, at my current company, it's more like a business style or business culture. It's I would say the business person who's kind of drive that, and data science more kind of supporting it and provide something that they don't have idea of. From my previous company at like a medical device company, it's more like engineering culture, and then probably the engineering person could be more likely to interpret the result. So my answer to that question could be, it's really dependent on the culture of the company and how people are working together. Does that make sense?
Yeah, I agree. Yeah.
All right. So I think there's a last question is there any common paths to transit from analytical position like business, data, financial analyst to data scientist roles. So this is more of a, usually it's the other way around, right? From data scientist, you want to transfer to a business, little less tech roles, like moving to managerial. And this is more moving from analytical positions into the data scientist roles. Any comments on that? Juning, Xiatian, and Liu Shen.
So I think, and Daniel just kind of pointed out, so this is more from like the front end to maybe like a back end, I would say. So if you are coming from the analytical position, so definitely you know more domain than most of the data scientists in how to understand the business problem. So that's a very good advantage. So I guess just learn more technical parts, understand the modeling, and also how to deploy this model and how to extract the feature from the data. And plus what you already have probably will make you a very good position to get into the data scientist arena. Yeah.
I think maybe the background is more like maybe this person will have 1 to 3 year industry experience as business analyst or data analyst, and then he wants to move to some data scientist role. I think in that case, maybe you need 1 or 2 projects. It's more to show your modeling skills or Python coding skills, and because you already have very good business sense in your like working experience. So you just have to add this modeling skills or coding skills to your resume. Maybe you're more likely to get an interview at first. So yeah. Okay.
Okay. My feeling is that as I forgot which presenter mentioned about 2 tracks, the business track and word like the analytical track versus a machine learning track. So my feeling is that for the people with a business background, he or she could potentially be a good fit for the analytical track. So just maybe more skill set in the two sets like Python or SQL, and then he or she could be very qualified, but it might need more for the machine learning side, probably much more machine learning, learning machine learning and coding thing. But for the analytical track, I think it's definitely doable, and it's not super difficult.
All right, so sorry, can you hear me now? Sorry, there's one more question is, how to set a 5-year goal, which is like midterm, to 8-year goal, like long-term in data science field? Like what department is definitely bad for career and you won't recommend? So this is more of a free-form question. What is your personal take? What do you want to avoid? What do you want to get into? And how do you set your long-term career goal for data scientist profession? Who wants to start first? I think, do you want to take that?
So Daniel, maybe I can start it. So like
okay.
Either Liu Chen or Tian can share their ideas later. So I think I don't know. I cannot like tell anybody else for their goal, but I can share how I see my goals there. So basically, I joined data science like probably three years around now. So that's the next 5-year goal. I probably would, hopefully after 5 years, I would be in like a managed track in data science. like positions for any industry. So it could be healthcare, it could be other high-tech industry. And for the 80-year, I hope, I mean, it's still in management, but I hope just it will be higher level so I can generate more impacts. Or 80-year probably would be starting something interesting, like myself, interest myself, so I can maybe like find a team to do some business or solution to help other company and the people to succeed. So to the second part, which department is bad? I would say this. So because the data science is very all exclusive, so it depends on many parties. So if you think the team or your manager do not really have a good vision how the team will be working with other people to help the projects to succeed, especially to solve the business problems for the company, probably the team need more guidelines, or even the company, they need more strategy planning for that team. So this might be not a good decision to do, or to a good team to go. If you think the team have very clear visions, how they want to leverage the data science skills or technique to help the company or deliver the solution or products, that probably will be a good position or good team to stay. That's I mean, this is still pretty general, but hopefully that's helped. Thanks.
All right, thank you so much. I think this is I think if Xiaotian and then Liu Chen doesn't have anything else to add, I think this might be it. I'm going to add just one more final touch on that question, the 5-year goal and 8-year goal. I just think that a lot of things are changing in data science. You guys agree, like 5 years ago and 8 years ago, the data science is not what it is now, right? So people looking back in 2012, what does data science entail? Really just traditional statistics, and maybe people just start getting to deep learning. There's not, there's no reinforced learning. There is no, the convoluted network. There's really a lot of things that does not exist at the moment. So I think we just have to be more open-minded. When you talk about data science, next 5 years, next 8 years, be on the lookout for the next big thing out there. Just learn paper, read up the techniques, and then try to make, stay relevant in this career. At the same time, you also want to ask your question, what is the long-term goal for yourself? Do you want to become, be kind of staying as a data scientist, maybe moving up the progression, or do you want to, own more on the business side? I think a lot of people are doing data science because you have true passion for data, which is great. But at the same time, there's a lot of other opportunities too, where you can start owning up maybe a piece of business once you know everything about, say, product or marketing or whatever. So there's also, maybe at one point in time you can think about, how can I take what I learned from data science and apply in the business directly? So I think just, be open-minded, be open to participate in discussions, seminars like this, or maybe just read a paper elsewhere, from a lot of the big conferences out there. And lastly, just have a plan. I think that's really the goal. How do you do career development and such? And I think this concludes the discussion. So again, really appreciate the 3 speakers we have here. Junling, Xiaotian, and Liu Chen, very great. Already received a lot of great feedback on the WeChat already. And if you haven't done so, please take a moment and scan the QR code. This is going to be a group dedicated to this event. So if you have an additional question, and might start adding more people to this with a future seminar, but if you have any questions, feel free to ask us. And then all of us do have some kind of job opening as well. I think Junling mentioned his email address, and we'll also, again, we'll type those out in the WeChat group as well. And I think it's on the screen, he mentioned earlier. And Liu Chen is hiring data science co-ops. So if you're entry level, be sure to reach out to him. He has something also, it's a great place to work at TJ Maxx or TJ Groups. So this is and I think maybe Xiaotian has opportunity as well. And for me, at Revolve, we also have 2 positions open, not specific data science, more on the BI and analyst, but a lot of skill sets are very similar. Less on modeling, more on storytelling and finding actionable insights. And again, this is appreciate all of the attendance, the speakers, the volunteers for making this happen. This is, this Sunday. You guys can, feel free to stay home and do something else instead. But this is, it's very rare for people to, stay committed and attend the whole 2 hour and 30-minute session. So this is the end of it. And please keep tuning on our WeChat, public account CYPN-USA, or join our group and we'll have you posted for future events. Thank you.
Yeah, thank you. Glad being here.
I appreciate it. By the way, this session is recorded, so we will also share that on YouTube once we figure out how to do that.
Thank you.
Thank you.